Hello again. I said in earlier videos that it's possible to model a system from the perspective of a requirement or from the as-built system. In this video I want to show examples of both using a very simple GUI application screen and see what differences are between the two approaches. There are certainly some lessons that you need to learn fairly quickly to get on top of the problem of modeling GUI applications in particular. I'll start with some simple requirements for a login screen, and we'll create a model from those requirements. And then, stepping back a little bit, we'll start again from the perspective of the as-built screen and work from the screen rather than the requirements. Now, one of the consequences of creating certain models is that the model will contain impossible paths, things that cannot happen. So we use a feature of ARD called constraints to eliminate these impossible paths. Now, once we have these paths that we trust are a good reflection of the behavior of the system, we can derive tests from them. And I need to talk a little bit about how we go from a path to a test and why a path may actually generate many tests. We'll see that later on. Finally, there are some important lessons to be learnt from what we'll do in the next few minutes. And these will stand you in good stead for when you come to model GUI applications in the future. So we're going to model a familiar, simple GUI interaction. Every system you deal with virtually has a login page, and that's what we're going to model. We'll create the models from two perspectives, from requirements and from the as-built screen. And it's clear the second model generates more paths, some of which are impossible. And so I want to use this feature called constraints to avoid them being generated by the optimizer tool in ARD. So this video shows how to create a model from scratch and how to refine it. And as we go through this process, there's quite a few lessons to be picked up. So these differences in perspective and how the model that we use to represent a requirement or an as-built system, there are some important considerations that perhaps you haven't encountered before. So one of the benefits of going through this more formal modelling process is it exposes gaps in the thinking that you might have applied in the past. Okay, so let's start with these requirements for our login screen. And I'll just walk through them very quickly. They're kind of obvious, but it's important that you look at these and say, well, and start thinking of how you transform a piece of text, almost narrative text, into a structured formal model. So the user is going to enter an email address and password. These are the credentials, as I'll call them. The checks that are performed by the system are the format of the email will be validated. It obviously has to be something at something dot something, perhaps. Invalid email addresses will be rejected. The password has to be at least 1 character long. This isn't a very sophisticated security system. Essentially, null passwords will be rejected. These credentials, a valid email address and password of non-zero length, these credentials will be matched in the user database, and there are two outcomes. One is the credentials are matched. The user record is in the database, keyed by the email address, and the password that's been registered for that record matches what the user has just entered. This is the valid login outcome. But if we go to the next stage, if the credentials are not matched, there could be two possibilities. One is the email address is not found at all in the user registration, or the supplied password does not match the registered password for that email address. In either of these two cases, the credentials will be rejected and the user does not log in. So you can see on the bottom left, this is a very straightforward GUI interaction, a very simple GUI screen which could occur on a website or a mobile application. They're so common that I'm sure you're familiar with these things. On this example, we have a login button, a register button, and a lost password button. We're going to ignore the register and lost password buttons and just look at the two fields plus the login button to perform a login process. Okay, what I'm going to do is create a new model. I'll call it login page. I'm going to not add very much more detail to the definition of the model other than the minimum to show you a working model. So I have a start and an end element in the model. First one is I'll add enter credentials. So this process includes entering the two fields, the username and password, and clicking the login button. It's user interaction, so we'll finish there. Okay. So next we need to validate the email address. So I'll create a decision block, valid email. It's a code action, I'll say. That's all I need. And I'm just going to create, as we go through the model, I'm just going to create the valid path, if you like, that logs the user in. So I'm just going to create all the decisions, but go through them one by one and create the straight through path with a valid email and password, which allows you to log in. So the next one would be valid password. Keep it simple. So this is the true branch. Okay. Just make it a bit smaller. And so we have a valid email and a valid password. Next would be valid credentials, as I'll call them. So here, valid credentials. Again, keep it simple, no other detail to add. And this is the true branch. Come down a bit further. Then we have another interaction, which is logged in user. And let's say you see the welcome screen. And this is true. And then to finish the completely valid login, we need the path to end. So if you like, from the start to the bottom, we've got start, enter credentials, valid email, valid password, valid credentials in the registration database. We log in the user, and there's an end. So now we need to put in the invalid email, password, and credentials rejected, if you like. So we'll create some processes over here, and this will be invalid email format, I'll call it. This is an error message, so let's change that block type so it shows up in a red. That's great, and we'll join that up, and we need to proceed to an invalid login process down here. So I'm going to create that here. This is not logged in. Keep it simple again, so I can go down here in parallel with the logged in user. That takes us to the end, and I can join this situation here, not logged in. Okay, I need another one for password too short. It's an error message. Finish. So we'll join that link there and complete the process down here. Finally, we've got the invalid credentials, as I'll call them. Can't find this user in the database, or the password is wrong. Again, it's an error. Finish, and I'll join it up. And there you go. And that's the complete model. So we now have the complete model for the requirements as described by a user. So a user in the requirements has said the email should be validly formatted, the password should be non-zero length, and those credentials must be found in the database, otherwise you can't log in. So when I come to look at the Path Explorer, I can generate, and I'm just going to go straight in and create all possible paths from this model and see what comes up. And we get 4 paths, which kind of makes sense. We have the first path, which is completely valid email, valid password, the credentials are matched, the logged in user. Second path, we have a valid email and password, but the credentials are not acceptable. We have a valid email, but the password is too short. That takes us to the not logged in path. Finally, we have the email not valid at all. So you can see from the model that we have these 4 paths, and that all makes sense. So I'd be quite happy with that as a model to walk through with a user whether their requirements were comprehensive enough to build a login screen. Let's go back. So what we've just done is create a model that reflects the requirements. Although the layout of this one is slightly different, you can see that the model is the same structure in the image towards the right. The flowchart is simple. There's a maximum of 4 paths, 3 error conditions and 1 successful login. Each error is simulated one at a time. Isn't this good enough? But we have a slight challenge, because now the screen's arrived, it might change our thinking. Let's look at the actual screen in use, and I'm just going to show you a graphic of what happens when you click the login button without entering an email address or a password, and you get both error messages. Now this is kind of not quite matched by our requirements, because in the example with our requirements, if I go back a slide, you can see that we only ever get 1 error, whereas in the real system we get 2 errors at once, both the email and the password error. So perhaps we should reflect this in our model. So let's have another attempt at creating a model that reflects this idea that the email and password validations are both performed and reported together. Now, why would actually this change have happened anyway? Well, it makes sense because from the perspective of the user wants to know of all the errors they've made on the entry to a screen, rather than having to fix one error after another. On a simple screen like this, perhaps it doesn't matter too much. But if you have a screen with, say, 20 fields that you have to complete, just to get 1 error message at a time, to fix 1 error at a time, is a bit kind of cumbersome and a bit tedious. So typically, developers will build all the error checking into one process and report all the errors as one process. So our model is wrong, okay? Our current model is wrong because it doesn't reflect this user interaction. So let's model the way the actual screen appears to behave as another exercise and see where that takes us. What I'm going to do now is go back to our original model and edit it to suit what we've just learned from the as-built version of the login screen. So it's going to be quite easy to actually make these adjustments. So let's work through it. So the first thing is we're going to validate the email address and the password separately. So the way I'm going to do this, model this, is to allow this path, the invalid email address, to come straight back into, to carry on the processing into the valid password check. And for the valid password check to, if that fails, to carry on into the valid credentials. Now, I need an extra process here just to help, so I'm going to make some space by moving these elements down again. Okay. I need another process here, beg your pardon, I need another decision here which says, are the credentials that supplied, are formats correct? So I'll call it valid credential format. Code action, we'll finish. So these outcomes from the password too short check will go in to this decision here, and this decision from valid password to valid credential format will come in here. So what we've done so far is we enter the credentials, we check the email address and register an invalid email format. We check the password and register a password too short message if it's too short, and then we come into whether these credentials are valid or not. If the credentials format is invalid, we'll come straight down into not logged in. It's the false branch. Okay. Now if the credential format is valid, we'll carry on into the check of the credentials against the user registrations. So if I move those up a fraction and just tidy up, this now reflects the way the screen actually works. It does potentially all three checks and will report an error message depending on the checks that it's performed. So now this is a better reflection of the as-built system. So you can see the flowchart is different this time around now, where both the email and password are validated every time, and we've allowed for the possibility of both the email and the password to be invalid, and that would add an additional error condition. So in principle we should have 5 paths or test cases. We should have 4 distinct error conditions plus 1 successful login. Let's go back to the model and generate all the paths again. So here we are with the model again, and let's go into the Path Explorer and generate all possible paths and see what comes up. Now that is a surprise, because now we have 12 paths, and I guess it's because of the combinations of all the decisions. We seem to have a lot more paths, but I thought we'd only have 5. What's going on here? Let's look at the paths individually. So the first path is we have a valid email, we have a valid password. No, we don't, it's false. The password is too short. We come into the check of the validity of the format of the credentials, and that check is true. Well, that's impossible, because we have a password too short. We should not be able to get through this check and the true branch. So that's an impossible path, or an impossible subpath, we could say. Let's look at the next one. It's the same path, but it's extended down towards the second half of the model. That's impossible too. That's the correct path. Invalid password, fails the valid credential format and comes down to not logged in. That's okay. That's the straight through, everything valid, logging in, no problem. That's no problem as well, where we have valid credentials, but the login process fails because there's no match, or the password is wrong in the registration database. That's an impossible situation. We've got a valid email and a valid password, but it fails the valid credentials check. That's an impossible path. Next, we have both an invalid email and password, but it passes the credential format check. That's an impossible path. That's impossible too. It just goes further into the model. That's the correct behavior. That's incorrect behavior. Invalid email should not pass the valid credential format check. And that's another impossible path. It just is extended further down the model. That's the correct behavior, where we have an invalid email and it fails the credential check. ARD provides a feature called constraints, which allows you to reduce the number of impossible paths, to eliminate them in fact. Now, the reason this is necessary is because an ARD model cannot evaluate the values of variables at what might be called runtime. So when you look at the path through a model, in your head you might remember that an email address format is incorrect, therefore it's impossible to get past the validation of both email and password formats. You can't get past that check. But the tool doesn't know that. So ARD in effect has no concept of state. It can't remember, the model cannot remember what you know to be the case when you execute a path through the model. Now, what an ARD constraint allows us to do is to specify situations that must not occur, but also situations that must occur. And by doing so, the model can eliminate possible or impossible subpaths. So you could instead, in principle, create a more sophisticated model to deal with these situations and actually have alternate routes. But what you'd end up with is duplicated actions in the model, and the model will certainly get more complicated and cumbersome. It would be harder to maintain if you need to change in the future. So by and large, that's not a good practice, and we wouldn't recommend that. So we use constraints to eliminate these impossible paths. We'll close Path Explorer and come to what's called Path Hints. And Path Hints has two features. You can create standard constraints and advanced constraints. We'll look at standard constraints. Advanced constraints are literally just more sophisticated checks to enforce paths that are impossible or paths that are inevitable, if you like. Let's create our first constraint. Must not occur together, and we could identify these fairly quickly. So the first one is, if we look at the valid email check, if the outcome of the valid email check is false, let's add that, we cannot possibly get through the valid credential format check as true. So we add that. And these two combinations, an invalid email and a valid credential format is true, cannot occur together, so we'll create a constraint. Let's create another one. If the password is invalid, add that item, again, it's impossible for us to come through this valid credential check. So these two cannot occur together. We create that constraint too. So we have these two basic constraints here. Now we need to add a third constraint, which is the situation where the valid email check and the valid password check are both passed. Clearly, if we have a valid email password, this check here about valid credential format can never be false. So the three elements that cannot occur together are valid email, we'll add that, valid password, we'll add that, and the false outcome of the valid credential format. Create constraint. We'll close that. So our three constraints now should reduce the number of path combinations. So let's go into the Path Explorer again. As usual, we'll look at all possible paths. And there we go. 5 combinations sounds more like it, doesn't it? So it looks like in this situation, when we create a more sophisticated representation of the as-built system, it looks like we generate more paths than are possible, but they are legitimate. But because of the inability of ARD to maintain state, it's stateless, if you like, these models are stateless, we get excessive paths, so we have to use constraints to reduce the number of possible paths. So the question arises, do constraints suppress useful test cases? Let's explore this challenge. If we add constraints to a model, of course, some paths are eliminated. So could it be that some of those paths would be really useful test cases, to validate that these impossible tasks, impossible paths are never executed? The question is, are we losing some useful test cases? Well, if our tests have expected results defined and the tester, when running a test, encounters an impossible situation because the expected result isn't matched by the actual outcome of a test, they'd flag it as an error in the application. There's something going wrong here. So I don't think we have a problem there. I guess the other side would be, it could be that our tests lack data for a path that turns out to be impossible. So when we generate our test cases, one test case might not have data provided for this impossible situation. So again, if the application goes down an impossible path, then our test case would be wrong because we don't have the data to keep providing to the application to carry on down an impossible path. We have no data, so it's an error in our tests, not necessarily in the application. Of course, there might be a bug in the application too, but what first comes up to the tester is that they don't have data to proceed with the test. It's an error in the test itself. So I think constraints that eliminate impossible paths shouldn't cause us too much concern as long as our tests are constructed and executed correctly. Now, up till now, we've been looking at the model from the point of view of whether it accurately represents the requirements or the as-built system. And I just want to explore a couple of questions here. One is every path a separate test? And I think that's kind of obvious that of course it is, because each one requires different decisions to be followed, and therefore there needs to be different data entered into the system, either from the database or from the user interface. Every path is a separate test. But is testing every path enough testing? Well, let's just look at this in a little bit more detail. Suppose you have a decision, which is the valid email address, the valid email format check. Now, we know email addresses have very stringent, well-defined rules. I mean, actually, the rules are terribly complicated. It's really quite a sophisticated validation that's required here. Now, testing that validation process might take many, dozens, hundreds of tests. But each time we run one of those tests, we're following actually the same path many times with different badly formed email addresses. So one path, an invalid email address, for example, might require many tests if we are testing the validation routine. Now, suppose the email validation routine is a library that we reuse from our infrastructure. It's been tested and used many times. It's trusted. We don't need hundreds of poor email addresses to test the path that we are concerned with. So perhaps one invalid email address and one valid email address is enough to test whether our system deals with the valid or invalid data correctly. So the number of tests we create depends on whether we're testing the component that sits behind a certain decision. If we're not testing that routine to destruction, let's say, we can just treat it as a kind of a black box with a valid and an invalid outcome. If we do want to test the validation process, perhaps it needs its own model. Perhaps we create it in our model as a sub-process, which itself has its own test cases. Now, what can we learn from what we've done so far? We know requirements are fallible, but even when the requirements are very simple, just a login screen, we know the implementation can differ from the as required version. So in our example, the requirements-based model kind of simulates the user's perspective. Any invalid outcome from the decisions will mean the credentials are rejected. It's as simple as that. But the second model reflects how the processing is done at the back end. So it's possible to have both an invalid email address and an invalid password, and these would be reported together. So although either of these invalid situations would cause the credentials to be rejected, the potential is there to have them both processed at the same time, and that's a usability concern on the implementation. Now, at the end of the day, the number of paths and tests can vary depending on your model, and you've got to judge whether your model is adequate and whether the paths that you do cover are adequate in order to test it. So you could say, well, our first model disregards the user interaction with the screen, and it's clear that when you look at the actual application itself, you could enter the data in any order and also make mistakes on any field at any time. Now, in the case of the models that we've built today, the order of entry of the data values does not matter. But in other screens, you will discover that actually the order is significant, and you need to pay attention to this perhaps. Going back to the two models, one based on requirements, one based on the as-built version of the software, which is the better model? So in our example, the extra test case might be important for testing the back end, but not important from the front end. So we'll look at testing GUI interactions in a later video. But you need to have in the back of your mind what your model is covering and whether what it omits or includes is significant or important. You know, the question is, are you concerned with the front end or the back end in your testing? And the model that you select and the modeling that you do should reflect the aspects of concern. Now, I can hear one or two of you thinking, hold on, I'm not happy about this. I never had to worry about this kind of problem before. I never had this problem when I do things manually, when I just create my own tests in a systematic way, say in a spreadsheet. But the significance of combination of errors might not be significant in this case, but in many applications, the combination of inputs and the outputs are significant. So what the modelling activity has done is it's encouraged you to think more systematically than you might have done before. It's included situations that might not have been obvious to you before. And because of this, you're getting a richer set of test cases. In the next video, we'll add data and expected results to our model, and we'll hopefully create some usable test cases that you could give to a tester to run. Thank you.